going to be talking about reflections. We've already dealt with reflections a little bit. We learned to identify them before, especially in comparison to other transformations. And today we're going to learn about how we can actually reflect a shape. So let's talk about the three different lines of reflection. And a line of reflection is going to be, in this case, the red line, the line that the object was reflected across. So in this case, the picture on the left would be my first image, and it has been reflected across this red line, which is our line of reflection, and it creates the second image. Okay. Your first image is called the pre-image. The second image here, what looks like a backwards E, is called just the image. So pre-image comes first. Remember that prefix pre means before. And then the second one is the image. Okay. This would be an example of a reflection across the y-axis. Right? So if this was drawn on a graph, then this red line would represent the y-axis. So that's one of the one of the lines of reflection we're going to talk about. Another one would be the x-axis. Okay, so again, if this is on a coordinate plane, this would be our graph. And it can be either way, right? But they will usually go through and identify one of the images as the pre-image and one of the figures as just the image. Sometimes that is by naming each coordinate on a figure. Remember that if each of these had a name on them, right, then if this is first, then this might be A, B, C, and D, and the corresponding points on the image would be A prime, B prime, C prime, and D prime. I'm sorry, that should be a capital B. Okay, so that's the second line we can reflect across is the x-axis. The third line is the line y equals x. And so if we were graphing just the line on a coordinate plane, that would mean that our slope, which we don't usually write in front of here, but it's going to be 1. So if you were starting on your coordinate plane here, and you started at the origin, you put a point there, and then you go up 1 over 1, up 1 over 1, up 1 over 1. So it's going to be this perfect diagonal line that goes exactly halfway between the x and y axis. And so this is the line y equals x. And again, they won't normally put that 1 in front of the x. You just need to know that if you were trying to figure out what's the slope of this line or something like that, that would be 1. Okay, so let's talk about this with actual pictures on a coordinate plane. Okay, what I have written in red here is your formula. So if we were graphing just a point, okay, and I want to reflect this point, we call it point A, across the x-axis. Okay, I have to first of all find my coordinates. So this would be -2, +3. And I would reflect that across the x-axis. That means if this is my x-coordinate and my y-coordinate, all I'm going to do is I'm going to change the sign of the y-coordinate. So the x value stays exactly the same. Okay. And instead of +3 here, I'm going to have a -3. Now keep in mind, this negative sign just means that the sign changes from whatever it was before to the opposite of that sign. It does not mean that every single time that value will be negative. I'll give you an example in just a second. So this would be my new coordinate A, would be -2, and then -3. So this is A prime. Okay. So let's try another one. Let's do this coordinate here. And we'll call this B. And so the coordinates for B are 1, 2, 3, 4, and down 1, 2, 3. So that would be 4, -3 is my original coordinates. And again, I'm going to change this sign here. So I go over here and the 4 stays the same. And I change the sign on the 3. So that means this time the 3 is positive. So this time I would go over 4 and I would go up 3. And this would be B prime. Okay. And if you had to do this for a shape, say like a square or a triangle, you just have to go through that process for each of the vertices. So you would take each vertex and you would use this formula, right, from xy to x negative y. That's your formula. And you would use that and you would be able to create each of the new vertices and then you would connect them. Okay, so let's talk about reflection across the y-axis now. Okay, so our formula has changed a little bit this time. And so this time, for reflection across the y-axis, we're going from coordinates xy to negative xy. So again, the thing that's changing here is the sign in front of the x value. So for example, we're reflecting point A, which was, its coordinates are -3, -4. The only thing we're changing is the sign in front of the x value. So that means instead of -3, it's going to be +3, and the y value stays exactly the same. So it's going to be -4. So we're going to go over 3 to the right, and then down 4. So that would be here. This would be our new A coordinate. Try again, this time with B. So our original coordinates are 6 and 2. And again, we're going to change the sign in front of the 6. And since there's no sign, that means that it's positive. So that means we're going to change it to a negative. So it'll be -6, and the 2 stays the same. So this time, you're going to go back 6, and then up 2. And that would be our B prime. Okay. Finally, we're going to look at reflections across the line y equals x. And that's right here. So let's have some coordinates. So first of all, we would have point A here, and we'll do point B over here. And the coordinates of A are -3, -2. And so again, we're going to start off with our original coordinates, and this is our formula. And this time you're going to notice that our formula says we're going from xy to yx. So all we did was we're going to take these two numbers and they are going to switch locations. Okay? So we started off with -3, -2, and we were just switching their positions. So that would mean this one will be -2, -3. All we did was take these two numbers and we switched them around. Okay? So let's try graphing that. So that would be back 2 and down 1, 2, 3. And this one actually ends up really close to the other one. And again, our line of reflection here is right through here. So those are just really close to that line. Okay. When we go to do B, the coordinates of B are 4, -2. Right, so we start with our original coordinates, and we're going to switch them. Right, they just switch locations. So our new coordinates are -2 and 4. So we're going to start back at the origin. We go back 2 and up 4. This is our new location for B. Keep in mind that for any reflection, the distance between the original point and the line of reflection, okay, in this case y equals x, and the new point and the line of reflection have to be the same distance. So if, for example, you had gotten on this one, that A is really close to this line of reflection, and A prime, the second one, was way over here or some, in a corner, then you would know that there was a problem, because this A is really close to the line of reflection, and then a point way over here would be really far away from that line of reflection. Now, it's not always foolproof in that you can't always see or count exactly the distance between the point and the line of reflection, especially on the y equals x. But, please use some common sense. And if you were to go and graph those, you should be able to see that they should be the same distance. They should at least eyeball it. You should be able to tell they're pretty close to the same distance from the line of reflection. So I look forward to seeing you tomorrow in class. Thank you very much.